this is one of the potentially most interesting panels that I've chaired in quite some time. Not only because we've got such a wonderful group of panelists up here, but because I happen to think the theme is, to me, and I hope to you also, very intriguing. We're talking about challenging the industry norms. Are yesterday's truths right for tomorrow? So we've got a spectrum of issues up across different topics to talk about. But before we get there and launch it off, I'd like to start with introducing everybody. I'm going to make that very brief since we're running behind time. I think you probably already know all of them already anyhow, but Mark Enright, VP of Customer Solutions at blank Subcom, no longer TE Subcom, right? And then you guys know he's got a long history with AT&T, technical production, all sorts of stuff, and doing a lot of sales-related stuff now, VP of Customer Solutions. Next, we have Alice Shelton, who needs very little introduction as well. Not only is she a leader in Sienna right now and all the upgrade work that they do and the lighting, but she has a long history in Alcatel Submarine Networks and in STC doing technical work in the early part of her career. And at least as important, she too is very pivotal in the suboptic planning. And so you'll see her up on stage again over lunch. Next, we have Tim Stutch, one of the greatest guys that I've met, one of the most helpful people in trying to share knowledge. So it's wonderful that he's up here today with us. I first met him several years ago as part of Sienna. Then he went to Microsoft. Now he's at Facebook. I don't know where you're going to be next, Tim, but it's great to have you right here. He's Global Optical Architect. Always has some terrific insights on a lot of things. Next, we have Soma-san. And Soma, many of you know also because RTI is famous in their own right and because Dagari loves Russ, right? So anyhow, Soma is Russ's right-hand guy when it comes to anything network and technical and all that kind of stuff. And he came out of SoftBank, so I'm really glad you're here because you've got a breadth of knowledge, and the private industry has a unique perspective on things, so thank you for agreeing to be part of this. Next, we have, of course, not needing an introduction as well, Alistair Wilkie, CTO of Deep Blue, but also chairperson of ACMA, so you all know he's got a breadth of knowledge as well. And last, but certainly not least, is Jörg Schwartz. You can read his title. Don't ask me what it means. He's a very important person at Xterra. That's what I see it as. So anyway, we've got a terrific panel, and I hope a terrific set of conversations. And we've got a lot of topics to talk about, but I think we're all open to stopping reasonably early because I imagine there are going to be lots of questions from you guys as well. So the way we're going to do this here is I'm going to make kind of a truth or false comment, and I'm going to leave it to the panelists. I'm going to cue one to respond first, and then it's just going to take off from there, I'm sure, with these personalities. Okay, so the first one is about system design, and it focuses on cost per bit. I only remember one time in the history of my career in undersea cables, and for those of you that don't know, I used to develop terminal equipment years ago, where getting the most amount of capacity on an individual fiber pair was not the preeminent goal of developing product. And we all know that Subcom moved towards C+L, and there were a couple followers, et cetera, over the last few years, and that's going in the water. But I think several people in the audience probably know that there's a change in the wind. So I'd like to start with Mark, immediately to my left. You didn't know you were going to be it, did you?
No, I didn't.
No. And ask you to start commenting on, is the most cost-effective solution these days, and in which markets where we have the maximum capacity per fiber pair, are we moving in a new direction? And if so, for how long?
Okay. So thank you, Elaine, and thanks all for coming. I assume you really want to talk about C+L versus STM and the trading technologies, but really what drives towards cost per bit. So the first I would say is that they're not competing technologies. It's what is the objective of a system? What are you trying to achieve? The fattest pipe? Do you need a fiber pairs as currency to allow for multiple partners? And those are both tools that can be used to design a system. As far as what's most efficient for cost per bit, you know, those other issues aside, just if you look purely at what's the cross-sectional capacity of a system, SDM versus C+L, it really gets down to fiber pricing and the cost of a C+L splitter and a combiner. So as long as a C+L splitter and a combiner costs less than the fiber, then the economics favor C+L. But as fiber prices go down or component prices go up, or the need is not purely cross-sectional capacity, there can be other parameters that drive towards that. But if the CAGR keeps growing for capacity, which every morning I pray it does, that the cross-sections needed in the future are going to be larger and larger. If you simply just duplicated the number of fibers, you're going to have massive amounts of fiber in a cable. And that may tip the scales back to C+L. We'll see. C+L is still viable. SDM is viable. And it all depends on what flavor of network you're trying to design.
I'd like to compliment Mark on assuming that everybody knows everything that he's talking about when he throws around these acronyms. And I know there are a lot of very smart people in the audience, and myself up here on the panel, I'll say myself as well. And SDM, lots of you have heard about it as space division multiplexing, which kind of fits. I think it's the way it's used these days in a little bit sexy exaggeration of the reality of what it's supposed to be conceptually. But Mark has assumed, I think, that you all know what SDM is in its latest flavor here, and I see a couple shaking heads saying, what the are you talking about, Mark? So, since you put that total wonderful thing together, I'd like to let somebody else on the panel explain a little bit more clearly what SDM really is, and then everything Mark said will make perfect sense to you. And while you're at it, maybe you can let the second person talk about why it works really well in some markets and maybe is not quite as attractive in others. So I can see Alice wants to talk.
I'm obviously not going to talk much because the microphone's so far away from me. So I think probably this is something that the panel is all going to agree on, that, as Elaine mentioned, traditionally we've been trying to push the capacity on every individual fiber pair up to the absolute maximum capacity, the biggest pipe you can put down one fiber pair. I think probably this is something we will all agree with, that there are now diminishing returns in pushing the capacity on a single fiber pair. There's something called, you've probably all heard of the Shannon limit, which is the ultimate capacity that you can put, the traffic rate you can put down, the traffic capacity you can put down a single fiber pair. And we are now getting very close to that limit. So just stepping back a bit, in 2010, when we first introduced coherent technology, we could achieve something like 12 terabits per fiber pair, a huge amount of capacity compared to the previous technology, and we was probably around 3 times away from this hard limit, this Shannon limit. Since 2010, we've had a second generation of coherent technology that probably gave us 18 terabits per fiber pair, then a third generation, probably up to 24 terabits per fiber pair, and the coming generation of technology this year, 2019, will be probably up to 30 terabits per fiber pair. And that is really close to the Shannon limit. Instead of being kind of 3 times away in 2010, we'll be probably 1.1 times away from the Shannon limit. So you can see from going from 12 terabits to 18 terabits, that's 50% extra capacity. Then we went from 18 to 24, that's 33% extra capacity. 24 to 30, that's only 25% extra capacity. There just really isn't anywhere to go after the current technology. We might have a few tricks up our sleeve, but you're going to get maybe 10% extra out of a fiber pair. And that's why there's been this shift away from looking at fiber pair capacity and considering what are we going to do? Well, we just got to put more fiber pairs in the cable. And that is the STM concept, spatial division multiplexing, is simply more fiber pairs in the cable. So how do we achieve that? Well, the wet plant suppliers are able to put 12 fiber pairs in a cable, probably 16 fiber pairs, very close. I'll let Mark comment on that, or Jörg comment on that. But we're probably up to 16 fiber pairs per cable. So as a SLT supplier, we've done a lot of modeling about what that means for transponders and modems that go on the end of these STM cables. And when we started, of course, looking for, as Elaine said, the lowest cost per bit. Now, we thought we'd be, maybe the concept has been to reduce the OSNR because you think you're going to be power limited, you're going to have less power feed equipment volts available to power the repeaters, reduced number of pumps, reduced output power, that's called TOP of the repeaters, TOP of the repeaters. And we thought maybe when we did this modelling, the lowest cost per bit would come out at pretty low OSNR, maybe 4 or 5 dB SNR, sorry, electrical SNR, with a top repeater output power around 10 to 14 dBm. But in fact, the modelling that we've done, we're not really power limited in most systems today. And so we're seeing that the SNR on new STM systems will probably be up around 10 dB, with tops around 17 dBm. And it means that the transponder technology that you can put down these new systems will be 400 gig single channel and above. So perhaps it's a slight surprise that actually will be up fairly high SNRs and high repeater tops for the time being. We wait for the wet plant vendors to increase the number of fibre pairs beyond 16 fibre pairs, and then maybe we'll have more of a power issue where the maximum power efficiency is seen at a much lower SNR and lower top. So have I explained a bit about STM and where?
Yeah. Tim, do you want to say anything?
I have one or two other, I guess, comments there. One of the ways that we talk about it is the net gain would be traditionally a fibre pair system. Let's just say you have 100% capacity on each fibre pair. Part of the idea about STM is if I double the capacity, double number of fibers, so I go to 16, if I get more than 60% of the original capacity per fibre pair on each of those 16 fibre pairs, I end up with net more capacity in the cable. So I go from, just to make up a number, 15 terabits down to 12 terabits per fibre pair, but I've doubled the number of fibre pairs. I get significantly more capacity through the entire cable. It's just divided up now into 16 chunks instead of 8. And that has some other implications for operations and perhaps what the SLTE and how you would operate, what modulation format and other powers. So that's part of the trade-off for SDM. Double the fiber or increment the fiber, less capacity, less performance per fiber, but net for the entire system is significantly more.
Sorry.
So I'm going to be a broken record. First, there won't be a test after this, but this is a very complicated, I think it's quite complicated thing to get your head wrapped around because it is different than we have done historically. And Mark, there was a great introduction to what we did, and I'm sure you could come back and explain it and wrap it all in a full circle very simply, but we don't have time for that. But come to SubOptic, and I suspect there's going to be lots of papers on this kind of stuff, and you'll learn a lot more, and then you'll pass the test with a 95% score after you leave SubOptic, okay? We're going to move on then to system operation and maintenance. And when I started talking to the panelists on the phone, to some of them I said, what was the first thing that you learned when you joined a submarine cable organization? And everybody that I asked that to said, reliability is number one. So that's the thing that we're going to question right now, because there have been comments in the market about whether reliability and availability is going to be as important in the future as it has been in the past, as meshes across the biggest routes become larger and larger. And you can do the math and say some things change, but we'd like to debate that a little bit. So the truth or the fiction is reliability and availability will always be a priority for a system design and operations plans for undersea cables. That means low fit rates for the components, well-engineered routes, and the shortest mean time to repairs, in other words, not spot market maintenance services. True or false? So since this ties into maintenance, and Alistair is going to be a cable owner with Deep Blue, I'd like Alistair to kick this one off, if he would.
Thank you, Elaine, and good morning, everybody. I think the maintenance issue really is more complex than a simple whether the spot market will work. If we go back a step and look at the cable and the fit rates and everything, I don't think it makes any difference to the manufacturers whether they manufacture a cable and amplifiers that are going to be good for 15 years or 25 or 30 years. The actual manufacturing process and the equipment that we use inside is pretty well going to be the same. So purely from a maintenance perspective, we're looking at whether we can get the repairs done quicker. And the main issue with that is number of ships and their cost per kilometre of cable. I'll correct Ian and from his last presentation saying it was done by fibre pairs. It's not. It's done just per cable nowadays. Very high fibre counts, yes, that will be a problem for us. If we go above 32 fibres in a cable, the speed of jointing is slowed down significantly. And there are techniques to use, other jointing techniques that we can do, particularly for the splicing, but they're not as good. So single fibre splicing is always going to be the way to go. And I think that's been found in cables across the channel in the UK, from UK to France, which have 192 fibre pairs. They are very slow to maintain. And they work, but it's just jointing time. And the issue really is shallow water cable, very high fibre count. And one of the previous talkers in the presentation this morning was talking about a multi-fibre cable up in the Baltic. Shallow water, bad weather, and you need 2 days to do the splicing. That's your issue. It's not an easy thing to do. But I think in the long term, if you put in more cables across, if we look at sort of a transatlantic system owner and they decide that 3 cables is probably going to be enough to get your 5 nines, but if they go for 4 cables, can they reduce the maintenance? And the answer is actually no. You still need to have a very good maintenance solution in place, and if you don't, then you're going to end up with problems because the systems don't get maintained, and the spot market, if there's no ships available, the spot market's not available.
Summer, would you like to do something besides nod your head in agreement?
I'm not sure if I can make a good speech on this one, but so for me, actually, it's purely depending on the ship availabilities. If you have a ship, you can make a cable repairs very quickly, but if you don't have a ship and you are on the waiting list, you need to wait. So that is happening in this industry, and it is actually, I think, not easy to control because it's purely depending on how many cable holds at the same time. And it's also depending on the regions. In the Pacific, maybe regions like US side, almost no cable hold. So therefore, you can ask cable ship to go to the repairs quickly. But if it's in the Asian regions, so always cable is cut. So therefore, usually you are on the waiting list. So therefore, pretty much difficult to maybe, I think, so if you say, so what is a target, let's say, availability figures, it is difficult to define. And so you can, of course, calculate. So assuming that maybe, for example, in the Pacific area, let's say, so 1 cable hold for, let's say, assuming every 4 months, which means maybe 1 week outage every year. So you can calculate how many cable you need to achieve a certain availability figures. So, but it's kind of, let's say, pros and cons on, how to say, cost and also maybe qualities, and maybe you need to give up at a certain point.
So we're talking a lot about maintenance and availability because I led in with that, but I'd like to also just ask the suppliers, has any owner ever told you it's okay to reduce the reliability of the cable that you build?
Go ahead, George.
Not really, I have to say. But there have been discussions for sure. And coming back to the comparison between 5 nines and 4 nines, or the reducing reliability, excuse me. Yes, I mean, when we make repeaters, it is a factor what components we use, okay? There is long lead times for high reliability components. If those could be replaced with lower reliability variants, right, that would reduce the lead times and the cost, okay? But now if you then think about what's the overall picture? You know, if you say I could reduce the cost of the repeater by using lower reliability by, say, 50%, okay, and let's say let's pick a number. The repeaters in a system make up about 20%, say, okay. Then my 50% reduction equates to a 10% reduction of the overall system price, okay. So, and then you have to take that with the increased effort of more repairs or restoration routes and so on. I think, so from my perspective, what's needed is a look at the whole picture. Right? Who do those compare? Mark, do you?
I agree. One thing, and it kind of ties into the SDM concept. So Alice mentioned the output power that's required, and kind of traditional systems are designed. You have 1 pump laser per erbium amplifier, And now in the realm of current system designs, we're kind of separating pumps per amplifiers. There's a group of laser pumps, so instead of just 1+1, one main one and one backup, there can be groups, 4, 6, 8, just this whole kind of ganging of pumps that are then fed to multiple fiber pairs. So a lot of the cost and the analysis and reliability has all been based around as if there's one laser and only it's one spare. Now that there's multiple spares and the pumping is sharing, the requirements on any individual pump can go down. So I think that can afford some interesting new paradigms in cost and availability. Effectively now with the same requirements, there's no contribution of pump failures to the failure rate of a system.
Tim's biting at the bit to say something.
So what I hear then is that we have more pumps per fiber pair, or we're sharing more of them, and I think consequently you can use less expensive pumps, right? So you get the 50% cost reduction.
Watch it, you're going to invite another cost reduction.
Yes.
We want to move on.
Actually, wait, hold on. I have one question for Alistair. He made a comment that was very interesting to me about the jointing time for high fiber count systems, and it's certainly not clear to me that I understand why, if we have an 8 fiber pair system, it takes a certain amount of time. If you go to 16, what I hear you saying is it's more than double the time. It's like treble or something as an example.
No. If you're going
or is it just a linear?
It's linear,
Okay.
but there are joint splicing techniques that you can use, which are sort of ribbon splicing, which will splice 8 fibers at the same time. The issue with that is the quality of the ribbon splicing is not as good because you're making some judgment, the machine's making a judgment on all 8 fibers at the same time.
Yeah. But maybe it's not only the splicing time, but also you need to wait for maybe mold is fixed.
So the joint is bigger.
Yeah, maybe it's joint fiber splicing maybe I think doesn't take so long, but after that you need to mold and need to wait maybe 24 hours or so.
Well, and so the reason that I wanted to ask the question is we did spend a little bit of time about SDM, right? And that but there's this whole operational piece that's if the availability goes down because it takes longer, so the team time to repair. So there's something that I'm not sure that we've discussed completely and should talk about more.
I'll just say I agree. Maybe the exact impact can be discussed and refined. I don't think it's that bad, but that's not surprising.
We could keep going on and on each one of these topics, but we're going to move on to the next one. Come to Suboptic and hear more. That's going to be my recurring theme. Okay, the next one is about system ownership. And I'm going to turn away from my friends in the audience who are part of the internet content providers, or the OTTs, because they're going to grimace perhaps at this, or maybe they'll stand up and put their own 2 cents in. But as I was reflecting on the consistent conversation in the industry over the past couple years about the Googles and the Facebooks and the Amazons, blah, 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 all driving the market, I thought, okay. And then along with that come some people saying, and the carriers are being left out, okay. But is this new? Or is this just one more of a pattern that investment and ownership in cable systems, just like a lot of other things in this industry, is cyclical? If you look back 20, 30 years, you'll see the carriers were doing exactly what the OTTs are doing now, right? And then the private network operators stepped in and did their thing. And if you look back further in history, and I called up our friend Nicole Stewart, I can never pronounce her last name, at the New York University and said, tell me the history, and certainly enough, there's been governments and private industry and carriers and a whole cycle over the past 150 years of at what stage in the life of undersea cable evolution different sectors of the industry were investing in the market and in new cables. So right now, we clearly see that Google and Facebook and Amazon have an inherent strategic interest, or they find it to be important to them to build their own cables for a variety of reasons and share them with others how that can happen. My question is this a phase? Like the carriers, to a large degree, AT&T and Verizon seemed to go out of that 10, 15 years ago when they had to put their money in other places where they saw more opportunity for value added and growing their business? Do we think, I don't think there's an answer to this, by the way, but that makes for all the more interesting conversation. Do we think that the OTTs 10 years from now will still be building their own cables, or will somebody Okay, Tim, go for it.
No, well, I have to, that's a default. Yes, of course. Just as a comment there, I think that in terms of whether it's a phase or not, all things change, and there's every company changes over time, so there may be other challenges that need to be faced in the future. As far as I can tell right now, we don't, if the demands on the business continue to grow, then the investigation of cable and pursuing them will continue. Hard for me to, I guess if I could answer your question, I would be very wealthy and maybe own a Hawaiian island. But beyond that, I think it'll continue. How long the phase lasts, though, I do agree that there seems to have been eras or epochs of cable development by different types of entities.
Soma, do you want to touch us with the 10-foot pole? You're doing a lot of business with other players and co-building with OTTs, and I don't know who's swapping with who these days, but I think there's a blend of different things going on, and I'd be interested in some counter opinions to somebody with a self-interest in this.
Yeah, actually, I'm not sure if I can disagree with Tim, but actually, I'm not disagreeing with you. Maybe I think since OTT is actually, I think, end users at this moment, and the end user has a huge amount of capacity requirement, and in this case, maybe I think end user may want to have a capacity at the cost basis. This is very normal, and only maybe I think a question is maybe I think whether maybe as far as you can comply with regulatory issues in each country, I think OTT keep going, I think. But the question, I'm not sure whether I can talk about the carriers, but how to say? So it's a company like RTI is jumping into this market and build and maybe sell, kind of build and sell models. So maybe I'm not sure, but so things may change in the future. Things may change in the future, but for the time being, maybe the users or maybe I think companies who requires capacity, who has capacity requirement, maybe want to keep building by itself, I think. So which is actually OTTs.
Does anybody on that side of the room want to talk about this at all or speculate? By the way, my question was not to second guess whether or not they'd continue to need more and more mountains of capacity. I'm pretty convinced that they will. It was really, will they find better things to do with their time and other things and buy capacity or buy fiber pairs? They're not going to go back to capacity, I don't think, from others rather than driving the bus. And I don't see any takers in the audience. Okay. Jörg, anybody else want to comment on this before we move on? No? Okay. The next topic has to do, again, with owning the global network and who gets a stake in what. And there were conversations in the first part of our workshop today about big new cables coming in and some smaller ones and feeding. Nobody talked much about some of the cables that aren't announced that are rumored to be connecting along the Eurasia route that in a lot of people's minds these days probably are going to connect big hubs like between India and Singapore and Europe and between India and South Africa and Europe and maybe up to the US through Brazil, who knows. But when those routes have been built in the past many years, there have been smaller places along the way that don't have as huge demand that have gotten picked up along the way and had the opportunity to connect into those cables through consortiums and investment in branches and the like. And oftentimes when we go through one of these refreshes of new cycles, somebody else had a different name for it this morning, I don't remember what it was. It's these big new routes that are built, and then you have kind of a regional build, series of regional builds after that that feed into it. Honestly, I don't know these days because I'm working more in big things across the Atlantic and across the Pacific and little tiny things elsewhere, whether the ones that are going on the routes that are usually kind of a hybrid of big anchors and little ones along the way are really giving the opportunity to the little ones along the way. And I have to ask myself the question, are we moving towards reinforcing the digital divide without having the refresh for some of these other places along the way. And I don't know whether anybody on the panel is willing to talk about that, but I'd be interested in what people's view is about serving the globe as a whole as opposed to just serving the data center market.
Yeah, I can. Shall I say it? Yeah. Well, I guess as Xterra, we are doing a lot of regional stuff, and from what I can say, my opinion is that there's a good reason to have both branches and regional systems alongside each other. Obviously, branches are good for people who have, we own a region where a big cable passes by, so that you are connecting to it, right? And there's a good cases for regional systems as they are, right? Interconnects of regional places. So for me, the drivers are different in that sense that for a branch, it's often about someone getting out, like a local carrier who wants to be connected to the rest of the world, is prepared to pay its part. As per the latest blog we've seen, or some of us have seen, maybe too much. But there's certainly that driver, or the OTTs who are trying to reach that particular country out of a system they're rebuilding in that region. But of course, geographically, there's also places where that doesn't work, or economically where the drivers are different, right? And I think we see cases where investors, people who see an investment opportunity, a build opportunity in a regional place. And I think that's also the other important aspect, I think, for the build of regional cables. So I think it really depends who's pushing for that to connect that regional place.
Sure. Elaine, kick me if I'm too technical. But it's when you're building a new system, it is really relatively cheap to insert in your cable a stubbed branching unit. So you may not have the investment to build the branch, but within your long cable, you can put in a stubbed BU for future connection to an underserved region. You don't have, all you have to do is define how many fiber pairs you want to drop. You don't have to define the capacity on that branch, because you can put in a reconfigurable OADM unit when you install the branch. So that the cost of an optically passive stubbed BU in the context of an enormous new pipe, DC to DC, is really relatively small. And then when you do have the investment or the reason to go back and put in the cable, you can go back, pick up the stub, and install the branch. And there are good examples already done where we've gone back later to pick up the branch. There's the Easy cable, which wasn't able to install the Mogadishu branch when the cable was originally installed. When it was safe to do so, it was picked up, the branch was picked up, and the Mogadishu branch installed. There's a more recent case, Main One announced last year that they're building from their stub BUs on the Main One cable to extend to Senegal and Ghana, which do have quite good connectivity, submarine connectivity already, but Main One's plan is to extend inwards to serve some under-resourced countries, Mauritania, I think, Burkina Faso, I can't remember the press release exactly, but they are going back to put in those stub BUs, so that's good for those regional countries. And I would say some of the big pipes that are being planned, that Elaine mentioned, there are plenty of stub BUs being planned on those systems. Let's hope they don't get taken out in the final cost-cutting exercise before the systems get signed.
I thought you were going to comment, Mark.
I can, if you'd like.
Sure.
Well, the only thing I'd say, you know, part of our product development strategy, of course, we want to service the large pipes and the large internet highways, but we also focus on small feeder systems, you know, where they're, every dollar matters, and try to come up with affordable systems for those, whether it's a branch or whether it's a small network that then taps into a hub point. So we try to serve both markets. Of course, those smaller feeder networks aren't super pipes, half a petabit with 24 fibers or whatever. There are a few fiber pairs and modest capacity, but that's all that's required to enable those systems to play on a level playing field.
There was an example this morning, I think, about Chile built a domestic cable to enable access to the southern part. I think there's some opportunities there for governments to behave like some of the municipalities in the United States that are now building their own cable networks. Perhaps that's something that they will choose to do to impact, you know, bring capacity to their countries themselves. Maybe.
Anybody else?
Yeah. looking at it from a slightly different perspective, I think one of the issues we have is that, yes, you can get very big pipes passing by small islands in the Pacific and in the Atlantic, but the owners of the big pipes must be realistic in how much money they can get out of the small islands. If you've got an island with a population of less than 10,000, then it's unfair for them, in a way, to say, well, you've got to pay full retail costs for a fibre pair all the way across the Atlantic, when they only need probably 100 gig or 200 gigs at maximum. And this is where governments have to come in and help for the smaller islands. And there has been some help. I know the French government are very good about doing what they need to do in the Pacific, but I think some smaller countries, particularly in the Atlantic, the very small islands, they do need help from the governments that own them or run them. And it is difficult to get the price point correct. And Mark, I know you're saying that you provide smaller, cheaper systems, but yes, that is important for the small islands.
And there's also one other aspect which we find often is relevant, which is control. I mean, that comes back to the SDM discussion, having your own fiber pair, right? If you build your own little regional system, you are in control. If you're a branch, you have much less control of what's happening. I think that's also an important point.
Yeah, and actually, I think I have a simple mind that so if you can make a business case, you build a cable system. But if you cannot build a cable. And in this case, maybe for such a small islands, maybe governmental support may be needed to build the cables. It's kind of more politics, not like a business, I think.
Okay, enough on that one. Thank you very much. The next one is one that we talk about a lot, and it has to do with system supply market trends. And as long as I can remember, everybody in this industry has said that the supply market is cyclical. And, you know, every consultant in the world in the undersea cable space, myself included, with my colleagues, have put together these charts that show how this cycle has changed over time, over the last many decades. And, you know, our conclusions probably match everybody else's conclusions, that the cycles, the periodicity of the cycle gets longer, and the amplitude of the cycle gets higher as time progresses, you know. And the one exception to that, of course, was the boom in the bus cycle 20 years ago, okay? But so now we're on an upswing. We're still, as I said before, well below the boom volume. But people ask us all the time, and I'm sure all my colleagues get asked as well, up here on the panel, get asked as well, is this another bubble? When is this going to go down again? Because we know that the industry is cyclical. And I think Alice, when she was you know, helping all of us to understand SDM a little bit better, talked about Shannon and the CAGRs of capacity growth versus technology evolution in the, did you say 40%, 33%, 20%, and eventually 10% kind of math. And so you see those slopes change. The question is this industry going to stay cyclical? I don't mean to pass it on to you, Mark, but that's your job, isn't it?
Well, as a supplier, I certainly support a continuing and increasing cycle. So actually, I'd defer to Tim maybe to prognosticate.
All you. Well, have you I was accused of being self-serving before you.
Yeah, right. Okay, well, I'll certainly be self-serving then. You know, clearly, as long as the capacity growth continues, 30 to 50%, that's a hungry animal to feed. So, and we're approaching limits on capacity improvements over generation to generation. So the 2x and 3x that was achieved before, we're kind of getting to the 10 to 20% type numbers. So it's going to be hard for technology breakthroughs to match the capacity demands. So I think you will see a certain continuation of the cycle. Hopefully it continues longer. Obviously, we're looking at a lot of technologies to try to match the cross-sectional capacity to the growth, but there's a lot of work left there as well. So I kind of, hopefully that, so certainly longer now. I think it's going to continue and continue to go for a couple of years, God willing.
So how does RTI look at it?
Yeah, actually, so what we see is our understanding is that capacity continues to grow, and however, so as people says, so capacity is reaching up to a theoretical limit of Shannon limit, And in this case, maybe I think you cannot expect much capacity on a single cable system in the future. That was happened like past maybe 10, 20 years. Past 10, 20 years, a new cable can carry more than maybe 10 times, 100 times capacity, but that doesn't happen in the futures. So in this case, maybe I think, so what I'm thinking that, so capacity continues to grow, but maybe I think growth rate may become slow down. So, but still continue growing.
But growing faster than technology still?
It's a good question. And if you look at the maybe, so memory size of laptop computers, so it grows very much faster. But however, so recently, how to say, growing speed is like slowing down recently. So, for example, like so number of gates in a chip. So it used to be, I think, Mr. Moore said twice every 18 months, twice every 18 months, but it was already slowing down. So in this case, maybe I think, so same thing happens in this industry. However, I don't know when it happens. But since currently, I think, in local access network is moving on to 5G, and also people are talking about IoT, so everything is connected to internet. So in this case, maybe you have more capacity demand, basically. And so primarily, I think we have a good reason to believe that the capacity grows. However, not sure when it's going to slow down.
So instead of wrapping up this part with a commercial advertisement for SubTelForum, I'll say, stay tuned to telegeography this afternoon, okay? But actually, before we do that, Tim, do you want to comment on this one?
I actually have a question because I hadn't thought about it. You know, the previous booms and busts revolved around sort of what I would call stagnation of technology, where it got stuck, right? Like, so 10 gig lasted for forever, right? Right now, we've seen in 5 years, we've gone through a couple, 3 generations of coherent technologies that have enabled a lot more capacity to enable, to make things continue to grow very rapidly. So does that factor into that traditional, or your view that you presented earlier? I'll ask Elaine you a question on the back and forth and the cycle nature. How much is that tied to the technology piece versus the commercial demands of the marketplace?
Well, to some extent, I defer to telegeography here, but my personal view is that the CAGRs are not getting any better in terms of technology keeping up. And I don't think of it, although that's a good way to say it, in terms of stagnating capacity, but I do think the solution has got to be some technology breakthrough, which we don't, I'm not smart enough to conceive of what it is right now, and maybe we'd have to turn to Mark or Georg in the audience or somebody doing forward-looking work someplace to say, what is going to be the key to unlock the growth capability back into the market? And I know Alice wanted to talk about other things that get deep in the, okay, so, but you have something to say.
Well, no, exactly as you're saying, Elena, and I think as people have said, there are probably no surprises in SLT technology coming in the foreseeable future. We had a great time going from 10 to 40 to 100 to 400 gigabit channels over the same systems. There are going to be no surprises like that in the future to increase capacity. It's got to come from the wet plant. So, yeah, the challenge to Mark and Jörg is what's coming next in the wet plant to increase the capacity to meet the demand, which is clearly there. Maybe not now, suboptic.
That's very nice.
2020, 2022.
If I could I respond to that?
What?
Could I respond, Elaine? If you don't mind.
To you,
Thank you.
Mark.
The one thing I just want to introduce, of course, we're working on more capacity, but I think there's obviously a commercial dimension to that. So if you look at some of the previous cycles, I don't think it was that capacity or technology stagnated and caused the stop of the cycle. It's the customer base at that time had achieved what it needed to achieve and no longer had a strong demand to continue investment. So, for example, precious dollars moved from undersea capacity to mobility, terrestrial mobility. So the fact that there wasn't 400G transponders did not cause that to occur. The need of the customer base changed and was refocused. So, you know, obviously there's a lot of work to do on the capacity and technology front, but always where dollars are spent and where they're most useful is what also influences cycles.
So how many fiber pairs are we going to be able to get across the Pacific in 2 years?
At least 16, hopefully a lot more. So, yeah.
I tried. He ducked. Jörg, you want to answer?
No.
No. Okay. All right. We're moving on to a new topic now. We're going to talk about suppliers themselves. DRG always gets the question, who should I release my RFP to when I go out there for a bid of a new system? And our traditional answer, and I'll say traditional with an underline on traditional, is for big transoceanic networks, there's 3. There's always been a European one. Now the European has gone through a number of evolutions with STC and Alcatel and Pirelli for a little bit. There's been AT&T, Tyco, whatever you call them now, Subcom, right? And then there's been a Japanese consortium with KDD in front, and now NEC and Mitsubishi occasionally, but you think of one Japanese. And we have Huawei now as well doing some major transoceanic systems, not all the way across the Pacific, but we now have Huawei, which means that maybe the big 3 is not necessarily the big 3. Maybe there's no stopping them. We've got all the security issues that Kent alluded to earlier. But the question that I'd like to put out to the audience is, are we going to have 3 or are we going to have more? It seems to me that some of the barriers, apart from the political barriers of entering the long-haul space, have started to be beaten down, but it takes a long, long time for a supplier to become qualified. I'm not sure anybody will take this one up, but I'm going to try.
This is kind of sensitive questions.
Elaine,
These panels were meant to be controversial. Is that Dennis back there? I see in the corner laughing out loud, you know, but Jörg, you don't want to touch it either as Xterra?
but I'll just say one thing as a cable owner, the more the merrier.
The
I mean, I was
more
going to
the
say,
merrier.
how much do we need? But no, I mean, for us as Xterra, and if you mentioned HMN, Xterra, I think there's a few people who are on it and trying to be suppliers, and well, we are suppliers, and the question is, who of the big 3 will drop out, so we become number 3, I guess. No. But on the serious side,
But I want to thank you for adding to this conversation, Jörg.
No, let me add something else. The way I think we've approached this as Xterra is we've tried to be innovative and maybe also a bit stubborn. HMN, as far as I can say, have done a lot of planning behind it and financial commitment. So I think there's ways to get in there. But the main point I think I was going to make is the entry barrier you mentioned, or the entry barriers, are also largely connected to the fact that everybody's looking for, or the customers are looking for, vertically integrated suppliers. And we've seen disaggregation on the terminal side, on the system side, the upgrade business we've, at Xterra, also started bringing into the market. If, let's say, as a mental experiment, if disaggregation would hit the wet plant, so that people would start buying cable from different people than they buy the repeaters from, that would lower the entry barrier to become a supplier, wouldn't it not?
It would. Some people have hypothesized that the open systems would become the beginning of the disaggregation. I'm not sure we're going to see that. And that leads very well into the next question, I think, which I think we're going to touch upon lightly because I think the lunchtime panel will get into it more. But it's around open systems. And you know, open systems have been talked about at this conference, at this workshop for several years now. I remember the first time I talked about them, we talked about naked networks, and Jane Stoll was up there on the slide in a bikini, if I remember correctly. But we're now, that was a picture to behold. She says no, but I think I have the proof. But anyway, I'd like to talk about open systems, and the big debate about open systems has consistently been, with them, is there an effective commercial way that's balanced with a technical approach to accept with confidence the system from the supplier and be confident in its performance and satisfaction of the warranty long term. And I think people hoped that there would be a relatively straightforward and easy answer to that question. And it's because it was so important to those who wanted to manage their own capacity on their own and choose their own SLTE provider. But the dream has not yet at all approached the reality, and so SubOptic has set up a working group to focus on this. But I'd like to invite the panelists to talk about where we are in this conundrum quickly, because I want to set it up for Liz at the next panel, but not go into it too much. But this is one of the favorite topics of all the panelists when I talk to them before this session, so I'm opening the floor.
Let me start. So, of course, I wouldn't describe it as a conundrum. I mean, it's a breakthrough in how systems are supplied, and obviously there's still a lot of work that needs to continue to, advance it even further. But it's definitely a successful model. It's definitely tremendous interest and demand, and it's just a matter of refining it. Of course, the SubOptic panel will be a seminal moment where both system suppliers, terminal suppliers, and customers are all working towards a standard of acceptance. I think we're very close on GOSNR and methodology, so I think that should alleviate some of the quote-unquote conundrum. But that's all I'd say, and I'll turn it over to my panelists.
Okay, maybe I'm not sure if I can speak on this one, but since transmission, maybe I think performance or maybe capacity is defined by in combination of subsea performance and terminal equipment performance. So therefore, problem for me is that we don't have any common measurement tool to measure the subsea performance. So what I do is that I just assume one of the maybe terminal equipment from one of the vendors, and so use that as a kind of a benchmark. And then so you can assume, you can estimate, so which supplier can bring more capacity or which supplier cannot. So that is currently I'm doing. So because, so OSNR is very simple. It's just a linear calculation, but also there is a GOSNR concept. So I understand that. However, it's also depending on the terminal equipment technologies, which is different for each suppliers. And actually, I am not suppliers, so therefore I don't have any such a kind of measurement tools. So that is kind of maybe I think a challenge to me.
Alistair, you look like you have something to add.
Yeah, I'm just going to agree with Soma-san, really. There needs to be some form of common measurement that we can refer to bring everything back to a common number that we can accept. Previously, it was very easy. You test how many channels you get down the system, and that's the terminal equipment supplier puts your terminal equipment on. But when you haven't got any terminal equipment, it's slightly harder. But I think OSNR or some form of that we can come back to a base measurement that's repeatable and it's reliable, and we can all agree on, then that works. But I think the suppliers need to come up with something.
Yeah, I just comment that there's the agreement of the measurement, the GSNR measurement, and how that's done, which is ongoing with the SubOptic working group. But then there's also going to be a question of who's responsible for doing that measurement, which seems to be a bit tricky at the moment. So the turnkey model was great, of course, because the wet plant vendors had the incentive of selling transponders and SLT on top of their wet plant systems, so they were quite happy to take the risk on the performance of the system and do the testing and the acceptance and the proving of the system. They're not really willing to do that anymore. On the other hand, the SLT suppliers don't have any control over the wet plant, so they don't essentially want to take the risk and be responsible for that either. So there's that commercial point, which Elaine mentioned, commercial point to resolve as well as the measurement. And if I can just make one other point about open systems. So I think open systems is not just, we don't want systems that are, or our customers don't want systems that are just open optically, but they want them to be open from a network management perspective as well. Mm-hmm. And so it's not something that this working group is looking at so far, but I think it's something that really ought to be done in the future, is develop a common info model or something of the wet plant that will allow some interface from the wet plant vendor's network management system into an overall operating system where customers can manage their entire network from one system. So next suboptic working group on open APIs or northbound interface. And if it helps, Sienna has already developed a draft spec. Thank you.
We're full of commercials today. Tim?
All right, a couple of things. I agree with Somozan and Alistair that with the lack of a clearly defined measurement, it becomes hard to accept, because in previous iterations when you did Q testing, it was quite straightforward to figure out, okay, this Q does this modem does this, I get this much capacity. They have delivered on what they signed up for. I think part of the challenge with the open cable acceptance is a commonality of the language, and as Mark mentioned, I think if we get to a de facto standard so that everyone is measuring things the same way and all the variables are the same, then you can go out and actually poll a wider vendor audience and say, here's these numbers that I got from acceptance, or that they're guaranteeing, what is your capacity estimate? And you should get pretty similar results based upon maybe technology refresh roadmaps are a little bit different, but by and large, and so you get a lot of consistency. You don't have one person telling you the cable does this. You can actually go poll a bunch and have better confidence. So I think there's some education that needs to be done there, and some at least acceptance of what those measurements are. And then I would throw up one last thing. The other part about this that's challenging is we've talked about SDM and high fiber count cables, and if the current version is 16 and we want to go to 32, and you stub something with 32 times 264, the number of DLS paths in the single system in the future is going to be number 1,000.
Yeah.
Do you want to spend 6 months doing acceptance on all of those paths, or how are we going to work out actually the pathing piece, which is something perhaps they'll talk about this afternoon as well?
And even if you have a standard, you know, with all the upcoming constellations and symbol rates and all that, that certainly doesn't make it easier. Yeah.
We have up here a list of another handful of questions, but I think actually it would be more interesting to open up the questions to the audience. Are there questions from the audience that people would like the panel to debate? You can see all the expertise up here to my left. Oh, come on. Nobody? Okay, Alice, I'd like to turn it over and let you talk about your favorite one that I think is particularly interesting that you just brought up before we came up to stage. I'll give you the mic.
Okay, so Elaine is referring to it's an extension to the point about only will there be 3 main wet plant vendors. So I said to Elaine, well, what about the number of SLT vendors going forward in the future? Will there be a change in that? So, I mean, originally, 20 years ago, we had turnkey supply, and the wet plant vendors provided the SLT. With the advent of optical amplifiers coming in, there was an upgrade market, and of course, all the new entrants joined, and were able to provide SLT upgrades. Now, what's happening now is that the technology in the SLT is becoming so expensive to develop that how many suppliers, SLT suppliers, will be able to continue to supply SLTE. So as an example, when we first did coherent technology, we would deploy the part of the guts of the performance of a coherent transponder is not just the optical, it's also the electrical. A very complex digital signal processor developed on electrical technology, CMOS technology, was developed in order to achieve coherent technology. And when we first did it in 2010, there were 8 foundries who could support the 32 nanometer technology that we had then. As we've gone forward with future second generation, third generation, and now fourth generation of coherent technology, the CMOS process has improved, i.e. it's got smaller and smaller gate size. So we're now on 7 nanometer technology, but there are only 3 foundries who can support that. So what that has meant for system suppliers is the cost, the number of foundries that can support, and the cost of the development of new DSP is so phenomenally large that they're now moving to, rather than developing their own technology, but to buying in modules and assembling sub-assemblies. and there are only a limited number of those sub-assemblies around. So perhaps in the future, there may only be 3 or 4 different technologies within the transponders. And if that's the case, then can all the number of 8, 10 SLT suppliers that we have, can they provide enough differentiation going forward in order to stay in the market? So perhaps, challenging the norm, there may be fewer SLT suppliers going forward in the future. Would anybody else like to comment?
I have a comment.
Good.
Well, certainly that's the case and something to be mindful of. One thing, not to get too technical, but with SDM, you know, right now, a lot of systems are nonlinear, so you have all this extra power, so you drive it past linear. There's a lot of wonderful nonlinear compensation that requires the powerful DSPs that Alice described to take advantage of that. But as you get more and more fiber pairs and you start spreading that power over more and more fibers, you're back into a linear regime of operation. So how much sophistication is really required in those transponders? Maybe we can get back to something simple like 16 QAM or something, and at modest baud rates, and that still gets you the pipe that you need and maybe allows a healthy supplier base of SLTE.
Good point. Anybody else?
Okay.
Questions from the audience before we wrap up on time virtually? Ken?
I have 2 related questions. The first question is, when are we going to see other content companies developing systems on an ownership basis? And the second question is, are we going to see content companies selling excess capacity on a wholesale basis?
Good questions, Kent. So I'm going to turn the first one to, dare I say it, to Soma. Since you're building cables into the obvious place where that might open up an opportunity. And if we were to put more specific words around what Kent just asked, to call a spade, you'd be saying, when are Alibaba and Tencent going to be building their own cables instead of buying from Unicom and China Mobile? Duh. So Soma-san, you're, I would guess, as close to them as maybe anybody up here on the panel, maybe with Mark aside, I'm guessing. Anybody care to comment, or maybe Chin-san is in the audience? Go on. Go on. No, okay. You go.
Yeah, that's a very actually difficult question, and I think they are coming on ownership basis, and having seen a successful cable building by existing, currently I think like these guys, or maybe I think other his friends, successfully building cable system. And if you look at this one, those existing maybe players, so I think they are coming on. And the question is maybe I think from which regions, and there may be some political issue also, and which I'm not sure. And what is the second question? This was.
I think the second question is for Tim, but Mark, do you want to touch the first one with the 10-foot pole?
Thank you.
I mean, you guys want to talk about Huawei, come on now. No. Tim, do you want to touch this next question? When are you going to invite regulation so you can resell capacity instead of swapping is really what he was asking.
You got to leave that to my planning colleagues if it's ever going to happen. I actually have a question back to Kento. Let's just say they showed up and you know, someone wins a deal with Alibaba and wants to land in the U.S., what's the FCC going to say?
Team Telecom.
No, well, okay, Team Telecom. I think, given what I heard earlier, I'm not sure, given the current environment, I'm not even sure NCP would have been allowed today rather than 5 or 6 years ago. That's my swag on that one, but I was curious what you thought.
Yeah, so the question comes back to you, Ken. What's the answer to that?
If you have a crystal ball.
I think there's been a distinction between traditional carrier services and submarine cable capacity. So the U.S. government has continued to license the Chinese state-owned carriers and NCP and Faster. We've got HKA and B2B pending right now, and private Chinese investment in PLCN. And I think the view is that still raises different issues and not the concerns that have been expressed about carrier services.
Thanks.
I'm not sure that's a crystal clear answer, but so I'm going to change the topic. Anybody else have any questions in the audience before we wrap up? John.
Thanks, Elaine. Mark mentioned. That makes better. Mark mentioned before about small regional systems. It was a fairly passing comment. Given that probably many more countries in the world are small countries rather than the large countries, although the large countries obviously dominate the big demands, I don't get a good feeling that there's much consideration being given by suppliers in really developing solutions for the smaller countries where, you know, 100G is big, a terabit is just unbelievable, and the ideas of trying to squeeze as much capacity as out of a cable as you've been talking about is only applicable in a small area. From the panel, what developments are really in scope and what opportunities exist to get much more cost-effective regional cables?
Yep. Thank you, John. So, just a couple of quick things. So obviously you still need a vessel to land, and the marine elements are large, but what vessel do you need and what capabilities are really required? So those are cost reduction opportunities. The cable itself, of course you need steel and polyethylene, but how much, what strengths are really required, and can there be material cost savings based on adjusting the material system? The capacity is low, as you mentioned, so clearly a low number of fiber count and a very different fiber count. So not super high tech, high capacity fiber, but kind of terrestrial grade type fiber. So all those can help, but there's a large barrier of starting a system. So what we're talking about, as George mentioned, was the kind of top 20–30%. We can optimize that to get it lower, but it's still quite a challenge, as you well know, to get to economic viability for even a small feeder system.
Of course, there's those elements which are fixed, the marine installation, the cable, they are the difficult ones. In the 20% I made up earlier on, yes, there's stuff, obviously repeater spacing is one. If you're not looking for high capacity, then yeah, you can think about special repeaters who are very long, have long spacing, that sort of thing I could think of. But yeah, I think that's no easy answer other than the usual, and I know John's, the old redeployment thing, but let's not even get there. Yeah.
Okay, with that, I think we have to wrap it up because we are a few minutes late. We need to give the conference organizers a chance to set up lunch. They will be bringing lunch right to the tables, and then concurrent with lunch, we're going to have a whole new panel up here talking about challenges of the future. I'm expecting it to be every bit as interesting as this one was. This is really great. I want to thank all the panelists here to my left for their contributions. They put in a lot of thought to thinking about this ahead of time. So thank you very much to all of you. And do come back for lunch. It's always really good here.